Friends, in this module, I shall talk about the role of DNA in disaster victim identification. After studying this module, you shall be able to understand disasters and their types, need for disaster victim identification, challenges in collection of the samples from the site of disaster cases highlighting the role of DNA markers in identification of the victim, categories of remains based upon decomposition, extraction of DNA from hard samples, and type of samples and their collections. Disaster is an event of serious magnitude causing severe damage to life and property. Casualties numbering more than 10 individuals at given time and place is considered as mass disaster. This definition can be modified according to local criteria of a particular country or city. Types of mass disasters include number one, natural, like earthquakes, landslide, floods, hurricanes, cyclones, tornadoes, tsunamis, and epidemic outbreak like that of H1N1. Number two, accidental disasters like that of train, vehicle, ship, building collapses. Number three, industrial disasters where gas leakage, poisonous substances contamination, and explosion can occur. And number four is man-made disasters like riots, war, explosions, terrorist attacks. Mass disasters can be categorized as closed or open. Closed mass disasters are those in which numbers and identity of victim are readily known, like in airplane crashes where list of passenger can be readily obtained. And open mass disasters are those in which numbers and identity of victims involved is mainly unknown. For example, World Trade Center tragedy, in which final list of victims remained undetermined up to several months. Mass disasters often leave human remains that are literally in pieces or burnt beyond recognition. In some cases, it may be possible to visually identify the victim, but body parts are so separated from each other and the remains commingle, making the identification virtually impossible without the use of DNA techniques. Although fingerprint and dental records still play an important role in victim identification, but these techniques require finger or intact skull or jawbone along with previously archived fingerprint and dental record. Therefore, DNA testing is the most effective technique to identify each and every portion of the remains recovered from the disaster site, provided that the sufficient intact DNA can be obtained from the body, tissues, and reference sample are made available from the surviving family members or some verifiable personal items like toothbrush, hairbrush, comb, razors, and dirty laundry of the victim containing his or her biological material for direct comparison of DNA results. Now, as regards need for disaster victim identification, it can be said that in many jurisdictions, some form of identification is required for issuing death certificate to enable the family members to get claims from insurance companies against the policies in the name of victim, receive pensionary benefits, and also to obtain remains of their loved ones to perform last rites. Now, what are the challenges in collection of the sample? Sometimes it may become difficult to connect the victim to a valid reference sample if there is no known or living biological relative or every immediate member of a family is among the victim. In international disasters, difficulties may arise to locate surviving family members or communicating with them. It can be a challenging task to deal with the family members of the victim when there is a dispute between them over the entitlement to receive the recovered remains or when biological non-paternity is detected showing illegitimate relationship. Collection of biological material from the disaster site sometimes become very difficult. For example, if plane goes down at sea in deep water, the recovery of the remains can be quite challenging. The very nature of the disaster, the extreme environmental conditions during and after the disaster affect the quality of the recovered remains, resulting into degraded DNA. Identification of disaster victim and role of DNA markers. For identifying human remains from burns victim, aeroplane crashes, and unmarked grave sites and other type of mass fatalities, DNA markers including STRs, mini STRs, SNPs, and mitochondrial DNA sequencing have been used. Few important cases are briefly mentioned here for highlighting the effectiveness of DNA marker in identifying the victim. Number one is Waco Branch Davidian fire disaster. On 19 April 1993, over 80 individuals died and their remains were severely damaged due to high temperature fire. Nearly half of the victims could be identified by dental or fingerprint comparison and anthropological and pathological finding, and remaining were identified with DNA analysis. This was the first case where DNA markers were used for identification of disaster victim. The markers included HLA-DQ alpha, ampli type polymarker, D1-SAT marker, amylogenin sex typing, mitochondrial DNA sequences, and 4 STR markers. The reference sample from the living relatives were collected on blood collection cards. When usable tissues from badly burned bodies were not available, the portion of the rib bones were removed for DNA extraction. Observed sample genotype were matched with predicted possible genotype based on results of relatives' blood samples. Another case is Spitsbergen and TWA flight 800 airplane crashes. On August 26, 1996, an aeroplane carrying 64 Russian and 77 Ukrainian crashed into a mountain near Spitsbergen, killing all individuals, including 13 crew members, were killed. Identity of all victims was established within 20 days due to rapid analysis of remains recovered from the site at approximately 0 degree. The analysis comprised of 3 STR loci, 5 mini satellites loci, through which 257 body parts were associated to 141 individuals. The bodies were identified based on the reference sample submitted by 154 relatives. In another case, on July 17, 1996, TWA flight 800 route to Paris blew up in the sky above Long Island, New York, killing all 230 passengers and crew members. Their fragmented remains were also identified with STR typing results. These early successes in identifying disaster victims with DNA testing paved the way for more recent cases. In another case, Swiss Air Flight 111 crash on September 2nd, 1998. This flight en route to Geneva, Switzerland, crashed into Atlantic Ocean. Over 2,400 human remains were recovered, out of which 1,277 were analyzed using DNA testing, along with 31 reference samples from the relatives submitted on FTA cards, and 89 personal effects like toothbrush, hair from comb taken from the homes of the 47 victims, as no relatives were available to serve as reference for them. The main challenge faced was that the living relatives were from 21 different countries. 13 STR's markers were used for linking the remains, and the genotypes of all the 229 victims deduced from the family relatives, and thus the victims were identified. Terrorist attack against United States. On September 11, 2001, terrorist attacks left over 3,000 victims at 3 different locations, that is at Pentagon in Washington, Pennsylvania, and Twin Tower of World Trade Center in New York City. In Pentagon disasters, 938 samples were analyzed for STR profiling, along with 49 direct reference blood stain cards and 348 family references. 5 male STR profile did not match reference samples and hence were classified as belonging to the terrorist who hijacked the plane. These samples were further subjected to mitochondrial DNA testing and were associated with Near Eastern DNA haplotype. In Pennsylvania disaster, 40 passengers along with crew and 4 terrorists were killed. 592 samples including 423 bones, 142 tissues, 23 teeth, 2 hairs, and 3 fingernails were collected for DNA analysis. 55 family reference samples and 50 direct reference samples were also collected. Based on STR profiling, dental record, and fingerprints, all the passengers and crew members were identified. However, 4 male samples which did not match family references and ascribed to 4 terrorists were further tested for mitochondrial DNA and were associated with Near Eastern mitochondrial DNA haplotype. In World Trade Center tragedy, the number of victims stands at 2,749. The biological samples recovered from the site were subjected to extreme pressure due to the building collapse, fire of 1500 degree Fahrenheit or more for 3 months following the attack. As a result, the remains commingled and became very fragmentary. The 10,017 remains collected from the site were analyzed using reduced amplicon or mini STR panels of single nucleotide polymorphism, that is SNPs, and high throughput mitochondrial DNA sequencing, and more than 52,528 STR profiles and 16,938 SNP profile and 31,155 mitochondrial DNA sequences were generated in an effort to identify the victims. Now, there is another disaster called Kedarnath flood disaster in 2013. On 17th June 2013, the Mandakdi and Alaknanda Valley of Garhwal and Saryu and Kali Ganga Valley of Kumaon, Himalayan, received a heavy downpour and the cloud burst, which resulted in flash flood, which was further intensified by the outburst of Besoka Lake, thus causing huge devastation. Heavy rains in the region led to extensive flooding, landslides, and destruction to the property and lives. About 4,120 individuals from across the country were reported missing and believed to have died after tragic flash floods and landslides. The mortal remains of around 550 victims and around 200 blood samples of claimants' relatives of the missing individual were sent to CDFD Hyderabad for DNA profiling. From the cases discussed above, it is evident that when conventional dental identification method fail, biological material such as DNA may provide necessary link to establish identity. Due to revolution in DNA technology, forensic DNA profiling has established itself as a gold standard for identification of unknown remains. The goal of DNA profiling for disaster victim identification is to extract as much as genetic information as possible from highly compromised samples. The dental tissue is resistant to incineration, immersion, trauma, mutilation, and decomposition. Therefore, it represents an excellent survivor of DNA, autosomal STR, mini STR, SNPs, and mitochondrial DNA, either singly or in combination, can be effectively used for disaster victim identification depending upon the quality of DNA and availability of the reference samples. Now, categories of remains based upon decomposition. The remains can be categorized based upon extent of decomposition. The approach to obtaining DNA from remains can differ depending on which category is being considered. Category number 1, remains displaying relatively few signs of decomposition. At the post-mortem examination, it will generally be possible to obtain blood sample from some areas of the body, and the internal organs and soft tissues will be largely unaffected. As the blood and soft tissues are rich source of DNA, obtaining DNA profile from remains in this category should present few, if any, technical difficulties. Category number 2 includes remains exhibiting partial decomposition. Generally, during post-mortem examination, there is no blood and the superficial soft tissues may show sign of putrefaction. In such situation, targeting deeper tissues is often more successful than attempting to use more superficial tissues as a source of DNA. Normally, tissue sample require additional treatment to release DNA and purify it from the cell debris and other decomposition products. The most common protocol employed is to use buffered solution containing proteinase K, SDS and DTT, followed by an organic cleanup using phenol or phenol chloroform mixture. Using ethanol precipitation or microfiltration further purifies the DNA. Other protocols have been designed to maximize recovery and minimize presence of inhibitory decomposition products can be used in cases of partial decomposition of the tissues. DNA profiling may also reveal DNA degradation exhibited as a gradual loss of signal from the high molecular weight loci. This degradation may be extensive enough to prevent a full profile from being obtained. Category number 3 is that there is advanced state of decomposition in the body. Typically, in this situation, most of the soft tissues lose their integrity and may have formed adipocere. Remains of bones marrow may still be present. If the remains are in such an advanced state of decay, obtaining a disaster victim identification DNA profile from liquefied tissue or adipocere is seldom successful. However, bone marrow provides sufficient DNA. Category number 4 includes fully skeletonized, including mummified or desiccated remains. At this stage of decomposition, generally only hard structures such as bone, hair, nail, teeth are available. Skeletal structures, bone matrix, tooth pulp are rich in mitochondrial DNA. They also contain low but typeable quantities of nuclear DNA. As the DNA is encased within a hard calcified matrix, it requires special procedures to purify it. Hair shafts are relatively rich source of mitochondrial DNA but contain only traces of highly fragmented nuclear DNA. Attempts have been made to prepare STR profile from hair shaft or other sources using short amplicon strategies. Now, extraction of DNA from bone, teeth and hair and nails. The extraction of DNA from tooth, nail, bone poses a significant technical challenge. The preferred starting material is either a molar tooth, preferably free from an amalgam filling, or approximately 1 gram of compact, that is non-cancellous bone. First, the surface of the tooth or bone is cleaned to remove surface contaminant. This is often done by sanding away the surface layer of bone in the case of a tooth, or by transient acid immersion followed by waxing. Next, the tooth or bone must be powdered. Two methods are generally employed. The first utilizes a specialized bone milling equipment in which a bone chip is enclosed in a vial with a heavy metal bar. The vial is then submerged in liquid nitrogen to render the bone brittle. An oscillating magnetic field is then applied This causes the metal bar to vibrate violently, pulverizing the bone chip into fine powder. The same effect can be achieved by grinding using a drill bit, but care must be taken to avoid generating high temperatures as a result of frictional forces. Once a fine powder is obtained, the DNA is extracted by enzymatic digestion using a buffered solution of proteinase K, DTT, and twine. The resulting extract is heavily contaminated with calcium, salt, leached from the bone, which are removed by mixing with concentrated solution of EDTA. Finally, the extract is cleaned and concentrated by microfiltration. In summary, it can be said that number one, the identification of human remains has been undertaken without the aid of DNA typing for many years, and a wide range of approaches are still appropriate for differing circumstances. During the last decades, DNA technology has been extensively and usefully applied to identification problems. Consideration should also be given to which nuclear DNA typing system to be used. If patrilinear relatives are available in genetic deficiency cases, a panel of Y chromosome STR markers may be appropriate. Of course, these do not have the advantage of multiple copy number. However, in majority of cases, autosomal multiplex STR profiling will be the method of choice. Whenever required, degraded samples are analyzed using mini STRs, SNPs, and mitochondrial DNA sequencing. In certain circumstances, mitochondrial DNA offers a number of advantages over nuclear DNA. High number of mitochondrial DNA molecules are present in every cell. Therefore, there is a greater chance of some templates surviving. It is relatively easy to extract typable quantities of material from hair shafts and other skeletal structures where the amount of nuclear DNA may be very limited.